Hi, this is Dan Prince, and this is a quick demonstration of a TripleO remote execution feature. Couple things we'll use, custom Mistral action to create a heat software deployment. This is something that I had a chance to sit down and prototype with Steve Baker at the OpenStack Austin Summit. Building on top of that, we'll use a Mistral workflow, which talks to a Zaqar queue, and finally just tying that in to the Python TripleO client to show how an end user could make use of all this. Jumping into my dev environment here, I've got a deployed over cloud with 2 nodes, and I've actually already deployed the code that I'm going to show you later, but just to start with the end result, let's look at what you can do with this. So OpenStack client has a new command, and let's run help on it so you can see the options. So there's a new execute command. It's got a couple options, the server name and the group. The server name would be a fuzzy match for any server that you've got deployed, and the group corresponds to the Heat software deployment group type. So that would be, script for shell scripts, could be Puppet, Chef, Ansible, and I believe Docker is also supported. And then just to demo this, I've got a shell script here that just echoes out the host name on a remote machine. So to run this, I can simply specify a server name. So specify compute. It's going to do a partial match on any compute node that's deployed. And then I can just add the shell script here at the end. Run this. What's going to happen is it's going to make an API call to the Mistral API. That's going to start a workflow. The workflow is going to run a custom task that creates the Heat software deployment. It's going to drive that to completion. When it's done, the workflow is going to send a Zaqar queue message back to the client, and we should see that right now. And then the workflow will finish, and the client will get one more message and know to exit. So that's an example for a single machine. So we can do the same thing on all our overcloud nodes by simply typing in overcloud here, and you can see how that works for multiple machines. So again, similar process. It's just gonna, it's gonna match 2 machines this time, which will actually start 2 separate sub-Mistral executions, one for each node it's going to run on, and then we're going to get the Zaqar queue messages back to the client here. So you can see the host name for the compute node is printed out there. We should get the controller node here shortly, and then when it's finished up, we'll get one more Zaqar queue message, and there you go. So that's basically how this works. So let's jump in and look at some of the code. I'm going to go into my undercloud now. So this is a standard instack install from Trunk Newton at the moment, but I've added into it a couple of extra pieces. The first thing is in TripleO Common, I've added in a custom action for the deployment, the Heat software deployment stuff. So this has already been installed. But this is a Python Mistral action that creates a Heat software deployment and drives it to completion. So that shows up on the command line. If we look at the Mistral actions, you can see, here's one called TripleO deploy config. That's the one that we just created with that, and so we can do an action get on it and get a little more information that way. You can see the inputs there correspond to what you would expect to be able to use to create a Heat software deployment. So we've got that. Having that installed, we can actually create a workbook. And so the workbook contains workflows. So these are a Mistral workbook that contains 2 workflows. One is deploy on server, and the second one is deploy on servers. So deploy on server you can see the inputs here very closely align with the custom heat software deployment task that I showed you. Just and so this has two tasks. One is to create the software deployment and run it to completion, and the second one is to send a Zaqar queue message back to whoever's listening. And a second workflow is going to operate on a set of servers. So here you pass in a server name, and what it does is it does a Nova list, matches all the servers that have that name, and then it goes on down here to call one of the deploy on server workflows for each one that it matched. And so two very simple workflows that we've got deployed, and so I've actually already created this workflow list. You can see it here, but if you look down here, these deploy on server and deploy on servers workflows, those are deployed, and those are the ones we're calling. So it's really, just an extra custom Mistral action, a couple of extra workflows, and then I'm going to go back to my host machine. In Python TripleO client, all I did was create one extra task called remote execute, and to drive this, not a lot of code is doing a whole lot of, has a whole lot of power here. The inputs here, you can take a shell script, which shows up as a config. We do create a Zaqar queue here. We've got a WebSocket object that's connecting to a Zaqar queue. And then it basically starts a Mistral workflow, and then it pulls that Zaqar queue down here at the bottom for that workflow to finish and gets messages back, displays them on the command line. So that's really it. So in summary, this is API-driven remote execution. One thing to point out is it does not require SSH keys. Things are executed by our TripleO agent, which is called OS collect config. That's the same thing we use for, sort of our greenfield deployment with heat, the same mechanisms here. And the last thing I would say is I think the power here is probably really in the workflows themselves. What we do with this, with Mistral workflows in TripleO is really where, the cool power, I think, lies here. The Python TripleO client stuff is cool for demoing, but, maybe that's not the end-all of this feature. A couple of links. I've got an Etherpad here with all the links to the code. If you're unfamiliar with TripleO or Mistral or Zaqar, there's a couple of links for the projects there. And thanks to Steve and Thomas for their heat and WebSocket. Thanks for listening.